Thank you, Raj Lakshmi, for inviting me, and thank you for the panel. Really interesting news. Hopefully, you can see my slides, right?
Yes. We see that you're starting to share content. Yes, we are able to see the slides now.
You're seeing the slides now?
Yes. Yes, please go ahead.
And yeah, so nice introduction. Really happy to be part of, and I see many teachers and professors joining this workshop. So happy Teachers Day in advance. Again, we're really happy in today. So my talk is going to be very a bit narrow. We will be just focusing on videos, and I'm not sure how many of you are looking for ways or have already looked at ways how AI can play a vital role in education or in particular this talk in videos. So maybe it might be interesting for you to look at that. Please feel free to. I would be happy to take a couple of questions from the chat, or you can also unmute yourself and ask questions. Okay, so let's get started. Now, if you look at it, right, so what we are discussing, so the video, I used before pandemic, this thing like how the state of video is growing and all those things. It requires a motivation to see why. In fact, paradoxically, we are actually talking on a video conference, which is going to be a recording also. So I also understand how important video is, and in particular, what for our use case, the learning video, and it has been growing at a very huge pace last many years. So that was on the consumer side, but on the enterprise side, I'm sure now everybody is a video creator, right? Right from universities to the individual content creators to all the way to the enterprises, right? Which are creating a lot of huge video different forms. Now, okay, so but what's the problem? You have seen Professor Harman's talk, and she was talking about how to query content for a course, how to make an interactive course in such a flipped classroom settings, how do you engage, right? And some of these themes that you might correlate, right? That they follow a rigid navigation, right? So you just get a timeline to interact with that, and you can just go forward and backward, right? I mean, you really don't, right? So it's literally lack of interactivity. Again, in videos you can just watch, and oftentimes learners gets bored, get out, right? All these kind of things that you must have already seen. Lack of indexing again. Given let's say if I give you 100 videos which goes recorded as part of the course and say, okay, tell me all the videos where the professor has shown some code snippets or shown a demo in the as part of the teaching material, you can't find that because there's no indexing, right? So again, difficult to again, and all of these things makes that when you have collection of videos, they become increasingly hard, difficult to manage, right? So you can't really search through them, right? Apart from the basic metadata that you have as part of the title or the tags that you give, and it becomes difficult searching them or navigating through them. So now I will be taking some time, and so I had some like a common of some feature slides plus some technical under the hood kind of story. So I will try and see, given that this audience is mixed, so I will try and keep the technical details to be minimal. But in case if you feel that you need some technical details, please feel free to ping and I can open that particular slide to talk more about that. But let's go at a high level view of what we are talking. So given these challenges, right, how do we go about solving these challenges in learning videos setting? So VideoCAD is a startup again. Rajlakshmi told you, right? It was a spin-off from Xerox's lab, right? And we had a good technology which was covered by patents as well as publication in top AI conferences over last many years. Many colleagues have contributed to this technology, right from Xerox Research to the VideoCAD itself. So now what we are talking here. So one thing that VideoCAD does is that for each video, it provides 3 indexes. So whenever you open any video on VideoCAD platform, you get these 3 features. First feature is table of content. So table of content works the similar way that you see in a textbook, right? That you will see a topic name and the page number. Similarly, this table of content would be there for each video where you will see a topic and the minute or second or hour where that topic is appearing in the video. And the thing is that this can be automatically generated for any learning video. So that's a key technological part, right? And so the first feature is table of content. The other feature is called phrase cloud, which show you some of the key concepts which are there inside a video. And the third thing is that you can search inside a video, like you can search for a particular concept and you will see a snapshots for all of these now. So this is table of content, right? So you can see an interactive table of content with the respective time. You can click on that, it will show you from where to where this topic is occurring in this video. You can click there and navigate. That's it. So very similar to a book, but in book it's a physical book you have to navigate. In a PDF you can just click. This is called phrase cloud, which is take this video and let's say it can find key concepts from that video. Again, these concepts are very domain specific. Like the kind of concepts that you will see for a electrical engineering video is going to be very different than let's say computer science video or let's say a psychology video. So and then what the user gets is user can click on any of these concepts and it will see the occurrences on the timeline and then it can jump to any of these, right? It just means that reinforcement learning has been talked about a couple of times in this time frame. That's why you see multiple of the yellow icons. Now, the third thing is the in-video search. So you can, if you are not able to get a concept from the table of content or a phrase cloud, you can always search for a concept that you would like to see, right? So in this case, you can search for, let's say, a concept called regression, and it will show you wherever in that video that concept is occurring. And then again, you can click and navigate to that particular. Now, one interesting thing is that if you do it, if you create this kind of a rich indexing using AI for each one video, imagine that in your course or in your conference or in your organization, you have thousands of hours of videos. You can put a search on the top of that, right? So for example, when you search for any of these things, not only you can search the title of the video or metadata, also the table of content and directly jump to that point. So that's a search that we enable. We have a product called Video Lake, which kind of organizes, like let's say if you are running a conference and that this is a conference video web page for a conference called NeurIPS, which is one of the highest rated machine learning AI conference. And all the years of the conference videos gets organized in a nice way. All of these come with a table of content and those things, and then quickly navigate to any point that you want. Or you can search in multi-year conference video series, and all of this search is very deep, right? Because every video is tagged with a table of content, phrase cloud, and in video search as well as transcript. Again, so once you do this deep tagging, you can learn about a lot of interaction patterns, right? So a lot of learning patterns. So like for example, you can see where somebody is spending a lot of time, right? So typically in long videos, if you apply some kind of analytics, what you would see is that the you will see a reverse exponential curve. Like a lot of learners would be active in the start of the video and then it decays like in a reverse exponential. But what we have seen from our millions of video, we have processed millions of videos and we have analyzed them, the learner patterns on those videos. We have seen that people, when they get an opportunity to click on these different table of content or a phrase cloud, you will see these peaks, like the peak that you're seeing here. In a typical video, it's a 2-hour long video, you will never see these kind of peaks. You will always see a reverse exponential curve. You will see peaks, but on a very small level. But when you give these extra indices, overall navigational patterns of learners change, and they indeed spend more time actually in the video rather than, so it's quite antithesis, because you would assume that if you provide indexes, they will spend lesser time. What we have seen from our real world studies is that they spend less time when they're confused, right? Where they could not find the content they're looking at. If they're able to find the content that they're looking at, they will spend the time. Okay, so a little bit of technological under the hood, right? Like what's going on? How are we creating these indices, and how these indices are being looked from the user side, right? So now these can be a little bit technical, so I will probably skip in the interest of keeping everyone at parity, right? But I will give you a very brief overview for the people who understand AI or algorithms, right? So particularly for the CS, it should not be a big problem to understand. It's fairly simple that way. So a video comes, right? So we only operates on recorded videos. So a video can come from, let's say, YouTube, or a video, let's say, recording of this conference. You can just download it from WebEx and throw it to our system, and we get an input video. Now we extract visual frames, which are like all the slides that you have seen from the starting of the presentation, right? We get those frames extracted. We also get extracted the audio, because all of us are speaking. So that audio gets extracted, and other video metadata with there could be frame rate and all those things, right? So when you get, so for example, if I have to create a table of content for this workshop, because this is a very visually heavy, like all the speakers are showing slides to talk about it, right? So one of the interesting thing could be that if I pick the slide title really well, that can give me a nice topic list or a table of content, right? Along with a second level POC could be the speaker, like who spoke when. That's interesting, but the slide level itself can give you a lot of details. So there are a bunch of pipeline which runs like on object detection, because this is not relevant for this one. This is usually done in when you have physical recording where somebody, a human, can occlude with the slides or a blackboard and all those things, right? In this case, it will directly come to the visual classification where we'll see what kind of frame it is. Does it contain slide, or like in a lot of times you have seen in this workshop also, the speaker has come in between, right? The slides were not presented. So there was a human there for the full screen. So we kind of take out those frames with the help of AI algorithms, only focus on slides. Once you do focus on slides, you can run an optical character recognition algorithms on the top of that. And once you detect text from a slide, then you can do a bunch of other algorithms around visual coherence and all those things to pick the salient titles from that, right? And that gets linked back to the time and gets presented as a table of content. The second thing is around the audio extractor, right? So this is a module which generates phrase cloud. Like, what are the key concepts that were discussed in this workshop? So some of the key concepts that we're discussing is education technology, organizational psychology that the previous speaker was discussing, right? Simulation. So all these concepts needs to be extracted, and somebody should be able to jump in at any given point of time, right? So for that, we create a table of, we create a automated speech engine transcripts. We create a speech transcript from this. We punctuate that using some algorithms, and then we extract some phrases, right? And all of these phrases are vetted from Wikipedia and other knowledge bases so that you try and make sure that you don't pick something which is not relevant. And then they can again rank according to a domain. Like the domain of this workshop is education technology. So we will try and make sure that we pick phrases which are relevant for this workshop or this audience, right? The people who are going to look at this recording. So that gets presented into key concepts with context and all those things. So now, what are the challenges in these things, right? So as a researcher, we will always see, okay, like, okay, this is fine. This looks very fine. The pipeline that I described, like what have been the challenges, right? So the challenges of multiple kinds, like the Zoom calls or the WebEx calls, got popular from last 2 years only. Earlier, even the conference used to get recorded in a auditorium, right? So you used to have different camera angles, right? You also see slides get built up, right? A lot of times the speaker might use animations and they get built up, right? And you don't even know which slide to pick. Where does the slide start and where does the slide end? So you need to make some algorithms to do that. Speaker can use multiple things, like the previous speaker was using slides and a video inside that, and even some virtual world snapshots. So how do you classify what is a slide or what is a demo or what is a video inside that demo, right? So you need to classify all those things. So those are the kind of some of the stuff that we do. Presence of objects, like in an auditorium kind of recording, you might see a lot of humans going here and there, right? You might have blackboard and all those conclusions. So we will skip this one, but I will show you like what we try and do here is that we try and see where the slide start. Like the slide start, this is like a starting of slide, but after a few animations, these circles keeps coming, and then you get a full slide. So using algorithms, our objective becomes that we try and pick these full slides so that there is no ambiguity in processing a lot of these redundant slides. That's one of the objectives. Then there is a like auditorium kind of thing. Then you need to localize where exactly the slide, right? And so in this case, you see a bounding box around this thing. This is put in by our algorithm, right? So it ignores all the other things which could be a noise when you read it through a text reader or a slide. Okay, so now, so visual frame classification, as I already told you, right? Given a frame, it can tell you whether it's a slide or a handwritten or a demo or a code walkthrough, right? So this can help you because if you do this kind of deep indexing, you can run queries like give me the speaker in this EdTech workshop which showed a video demo, right? You can run that kind of queries on your video, recorded video, right? Or you can run queries like give me a Python Django video which has a demo into it, or give me a regression video which has a code walkthrough into it, right? So you can run those kind of queries, and we will be able to return you a video with the actual pinpointing the time where that code walkthrough was shown, let's say for a regression video. So these are some of the challenges. I will not go into detail at this point of time, but just coming quickly to the summary, what VideoCAN's technology does is provides quick summary outline for the end users. So there are a lot of if you put that video on YouTube or any other search engine, right? So if you put table of content, that helps in better discoverability of your video. So that becomes extra point, right? Extra brownie point for them, because they can index video, they can index text, but they can't index videos. So if you put that text out, it helps search engine and in general your content. And then you can build deep search and recommendation engine, right, on the top of a set of videos. So you can build your own personalized portal for your own course or your own department or your own company or whatever that is. Okay, so I see there are some questions that are coming on the chat, but let me take that in the last. Let me cover a couple of other slides. And so now, I mean, personally, I have spent quite a bit of time, maybe the last 5 to 6 years, working in education technology. And I mean, again, we have earlier worked on education pedagogy and all those things, but over time, I think from a skill set perspective, we figured out that okay, I think for us the AI in education combined was more interesting, and in some way that worked for our skill sets to say okay, to whatever pedagogical innovation is being done, right? How can you make it scalable, right? So, for example, one pedagogical innovation that Professor Sana was talking about having a reflection, like you teach a concept, then immediately test that concept using a just-in-time assessment or just-in-time question, right? Now, that's an interesting, proven way of keeping an engagement, keeping learner retention, a very, very helpful pedagogical innovation. But how do you scale it, right? Because you can't expect all the teachers around the world, right, to keep inserting these questions all the time, right? So specifically, it becomes a little tricky, right, and it becomes an extra burden on the teacher. And you have all kind of courses going on. Some are curated, some are created. You might have more energy on created, but some are curated, right, where you don't want to put that percent. So some of the interesting AI algorithm which can be built is that if you have a few bank of questions and you have a good video content lying with you, right? How do you marry? How do you make sure that right questions get inserted in the right videos, right? So you could configure, and maybe the humans can probably verify, as SME can verify this thing to start with, but at least the initial insertion can be done using an algorithm, which saves time for the SME. I mean, because it might be a hassle for insert questions and like that in all those things, right? So that's the first research question, which like could be an interesting master's thesis or whatever, right? The other interesting thing could be given that you question bank can never catch up with the video content, right? Question bank is always lagging behind. It's pretty focused on small. So how can you even make algorithm which can generate questions from video content itself? Right? Like the one that you see here, this question is actually generated using an AI. But this is fairly easy to generate also. It's a very simple, like a fill in the blanks kind of question, right? Where did you what's name, right? So AI algorithm today can generate this question, but again, now the technical challenge, which challenge is that how do you build meta level capability, which can take concept and generate question which covers both these concepts, meta level, right? Fill in the blanks or directly like a definition kind of questions. And both of them scalability to these pedagogies. Another thing is personalized learning paths, right? So you see YouTube, all of you must be YouTube and learning, right? So then now there are other meta websites which are coming on this works on the top of YouTube, for example, right? Where the key challenge is that the people who the learner, every learner background is different, and it's not like there are courses which are built by Coursera, which is essentially a learning path. Then there are courses which are built by Udemy, also a learning path.
All right, I think we've lost connection with Kuldeep Yadav. We'll resume in just a minute.
Hello? Oh, really? Okay. Okay. Razak Singh, can you hear me now?
Yes, yes. Your voice was breaking up. Maybe turning off the camera might.
Oh yeah, let me do that actually. So. Okay. Can you hear me now? Can you please confirm?
Yes, yes. Please go ahead.
Okay, sure. Thanks. Sorry for that. Let me go to the. Okay. Yeah, so I was talking about the learning part bit, right? So, given a learner's background, can you automatically generate a learning path, right? For example, you have a Django developer who is interested in learning semantic search. So, looking at the YouTube content which is already available there on semantic search, can you try and pull together the one learning path which might be most easier for him or her to get started, right? Again, it requires mining of different kind of information, so it's a very, very high level question. Question answering on a video collection. So question answering on a piece of text is already like there are algorithms for doing that, but specifically for video, which has transcript and all those things, it becomes a bit challenging. So again, there are interesting research challenges on doing that. So if somebody is interested in AI plus edtech kind of direction, this is an interesting direction where you want to run more semantic search on a bunch of video collection. Okay, so so I will probably stop here and see if there are questions. Let me just pull out the questions tab.
I can read them out to you, Dr. Yadav. So we have one question about exploring key areas in which colleges would need to make changes to improve the Generation Z student experience in online mode. What are your thoughts on that?
Yeah, so Gen Z student experience. So I think one key area is probably make the LMS more interactive. So the traditional LMSs that we use, right, are little bulky and have follow very rigid structure. So today's Gen Z is more Instagram and Facebook friendly generation, right? So for those, it may be better to have more like a smaller videos, nearly lightweight LMS, right? Good tracking, bit of gamification, right? And that bit of badges and honors, right? So that kind of experience we need to create, which is more sticky. And you can see that, right? At least in US, there is a growing success of platforms like Piazza and all those things, right? Which works on gamification and all those things. So that helps a lot.
And what you presented, the ability of allowing queries, the kind of queries you were referring to in learning videos, it of course very certainly changes and improves the experience of the student who is going through these videos, right? So my question is, can these algorithms, these indexing algorithms be integrated with LMSs currently? Like,
So
like platforms where there already are interleaved questions, or through the H5P plugin where questions are already there, can they be integrated like with Google Classroom or Canvas or?
Yeah. So they can be. So like the one that we provide, like the indexing capabilities, like table of content, phrase cloud, right? So we provide an embeddable player which can play inside LMS. And in fact, most of our content, right, in VideoCAN was consumed through an LMS. So nobody consumes videos as a standalone, at least in education, right? So we have big clients like Kaplan in US, right, which consumes the content through their LMS.
Okay. Yeah.
And similar with the questions, right? The questions appear inside a video, inside an LMS. So you don't really need to.
Right. And Ankita was asking the next question: how do we know what kind of indexing would be better received by the end user? So, what role does the preferences or you say pattern of usage by the end user play in this kind of decision?
Yeah, I mean, interesting question. So I think we so I think one of the proxy to find that is look at the usage patterns, right? Like what is being used and what is being ignored, right? So at least for our technology, what we have seen is whenever there was a table of content that got heavily used as opposed to a phrase cloud or a search, right? And so if you look at the usage patterns, the TO's table of content was almost used by 70 to 80% of the people who were looking at the video, right? The phrase cloud is probably 40 to 50%, right? And the search is very minimal, maybe 20% or even less than that, right? So I think they are built for a different use case. Like they are, some of this is for completeness also, because you only get to the search when you don't find some concepts in table of content or a phrase cloud.